Hello and welcome to this Python tutorial. So in the following tutorials we're going to implement the Apriori algorithm, and as usual we're going to make this machine learning model to create some added value in some specific business. And in this part, this business problem is going to be about optimizing the sales in a grocery store in the south of France, and you're going to perfectly understand how the Apriori algorithm is going to do a perfect job at doing this, optimizing the sales. Because recently, a lot of stores considerably created some added value thanks to machine learning and especially association rule learning by using it to optimize the sales of their products. And how did they do that? Well, they just used association rule learning to know exactly where to place the product in the store. You know, for example, I'll give you a very simple example. If someone buys some cereals, well, this same person is very likely to buy some milk as well. So, by placing the cereals close to the milk, the store is very likely to put these two products into the same basket, even if the buyer originally intended to only buy cereals. Or I can give you a more general example. Suppose a person wants to buy a specific product, let's call it product A, and this product A can be associated very well to another product B, and the person who wants to buy the product A might not think of this good association between the product A and the product B. Well, if you place the product A and the product B next to each other, well, the association can suddenly pop up in the buyer's mind so that, the buyer can tell, hey, that's actually a good combination. Why don't I try these two for my next lunch or something? And so again, even if the buyer was originally meant to buy only the product A, well, due to this association that popped up in its mind, thanks to the placement of product A and product B next to each other, well, the buyer finally buys the two, product A and product B. So that's the idea of how we can create added value for retail stores or grocery stores. And so what we'll make in these future tutorials to optimize these sales can be also applied to any other store that is selling some different products. You can think of an online store. You know these recommendations, people who bought this also bought that. Well, these recommendations are based on association rules as well, but not only. It can be also the result of recommendation systems like collaborative filtering or content-based, item-based collaborative filtering, but association rule learning has a role to play. So now let's make our first association rule learning algorithm, which is the Apriori model for this specific store in the south of France. So let's do it. As usual, we're going to set the working directory. So let's go to File Explorer here, and then let's go to our Machine Learning AZ folder, and part 5, Association Rule Learning, and we are now in the Apriori section, which contains an unusual thing. It's a specific folder for the Apriori model implemented in Python. That is here the Apriori Python. So let's open this folder, and that's actually the folder we want to set as a working directory. And why is that? It's because in this implementation of the Apriori model, we are not going to take any package directly in the code. We're not going to use some import to import some specific package like we did the usual way. What we're going to do is actually use this apriori.py file, which is an implementation of the Apriori model taken from the Python Software Foundation. And basically what this file contains is some classes that we will use to build the rules for our specific business problem. So we don't have to open it or anything. You can have a look at it in, a text editor. You can have a look at the classes and the different functions. It's actually quite intuitive, but we don't need to open it. However, we do need to have it in this folder when you execute your code here, which will be in this apriori.py file. So not to confuse anything, this is apriori.py file as if it's the library that we're importing as we did the usual way. And this is our apriori.py file that we are about to code right now to build the rules. And this is, of course, the dataset. So bottom line is that you must have these 3 files here to be able to properly run the Apriori algorithm for our business problem. Okay, so we are all set. We can click on this little button here to set the folder as working directory. And now we're all good. We're ready to start building our Apriori model and build the rules. Okay, so first thing as usual is to import the libraries. So let's do this. We're going to go to our data preprocessing template and just take everything from here to here because the a priori model is a special type of machine learning model. So We won't need to do any splitting of the dataset into a training set and a test set. No need to do that. We just need to run our algorithm on our dataset. So let's copy this and let's paste it in our Apriori Python file. Here we go. So let's immediately import the library so that we don't forget this. Here we go. Libraries well imported. Okay, and now let's import the dataset. Of course, the name of our dataset is not data.csv, but it's market basket optimization. Here we go, and now we can actually select this line and execute. All right, dataset well imported. Let's have a look. Let's go to Variable Explorer, and here's the dataset. All right, so this dataset, what is it about? Well, first what we can see here is that this line here contains some different names of different products of this grocery store. So of course, you know, this line is supposed to be the line containing the titles of the columns, and of course, you can already see that these names here are not the actual names of the columns. Well, that's because these names are simply the names of the product in the first transaction registered by this manager of the store. So the problem is here that Python thought that this first line of the dataset contains the titles of the column, and that's actually not the case. So we just need to do a little something here to specify to Python that there is no titles in the dataset. And in order to specify this, we need to add this header argument here, and that we must set equal to none. All right. And now you'll see that if we select this line again and execute, well, the dataset is re-imported with no titles this time. And now you can see that if we have a look at the dataset, well, indeed, I'm going to enlarge this. And here we go. We don't have any titles for the columns, but you know, this first observation is no longer seen as the titles of the columns, but that's the real observation itself. Okay, so better, and now let's describe the dataset. So as I told you, we're making this a priori model for a store in the south of France. And so we want to find out the association rules of the different products of this store to see how the manager of this store can optimize the placement of its different products to optimize the sales. Okay, so the first thing to say now is that this store is located in one of the most popular places in the south of France. So a lot of people go into the store. And so, you know, this place is a very convivial place, a very friendly place where people love to hang out, relax, talk to each other. And so these people come very often to this store because even if it's not to buy something, it's at least to meet their friends. And therefore, the manager of the store noticed and calculated that on average, each customer goes and buys something to the store once a week. So this dataset here contains the 7,500 transactions of all the different customers that bought a basket of products during a whole week. Indeed, the manager took it as a basis of its analysis because since each customer is going on average once a week to the store, then the transaction registered over a week is quite representative of what customers want to buy. So based on all these 7,500 transactions, our machine learning model, our a priori model, is going to learn the different associations it can make to actually understand the rules, such as if customers buy this set of products, then they're likely to buy this other set of products. So that's what we want to figure out, and that's what our a priori model will tell us. Okay. So each observation line here corresponds to a specific customer who bought a specific basket of product. So for example, if we look at line 2 here, that corresponds to one customer who bought burgers, meatballs, and eggs at a specific time of this week. And that's the same for all the other observations that correspond to other customers, or maybe the same customer who went back to the store another day or another time. So that's what this dataset is about, and now that we understood the problem and the challenge, let's actually make the model. So I'm going to click on OK here, and here we go. So the first thing important to understand here when we use this a priori implementation of the a priori model is that we need to import the dataset in a specific way. As you can see here, the dataset is simply a data frame where each line represents the different transactions of the customers in the store. And so So that could possibly be an input. So that could possibly be the input of the a priori function that we're going to use later, but it's actually not the case. What the a priori is expecting as input is actually a list of lists. That is a list containing the different transactions, each one put in a list. So, there's going to be this one big list containing all the different transactions, and each transaction is going to be a list itself. So that's not how the dataset is structured right now, because it's simply a data frame containing all the different transactions in rows. So first of all, each transaction is not a list, and the whole dataset is not a list itself. So that's what we're going to do right now. We are going to prepare the input correctly for our a priori function that we're going to use later. And to prepare it correctly, we are going to build this list of lists. Okay, so let's do this. It's going to require 2 for loops, because we're going to loop over all the transactions in the dataset. That's the first loop. And the second loop will be about to loop over all the products in each of the transaction. So it's going to be quite simple. It will perfectly make sense once the loop is ready. Okay, so first of all, as always, when we make a loop, we have to initialize the variable that we're going to use in the loop. So this variable is, of course, the list of transactions, and so we're going to call this variable transactions. All right. And to initialize a list in Python, we simply need to put some square brackets here, and that creates an empty list, an empty vector. Okay, so that's the first step, easy step. Now let's start the loop. Okay, so as I told you, we're going to make 2 for loops, and the first one is used to go through all the transactions. So to do this, we're going to start by typing for, and then we need to specify a name for the index that is going to be I, and I is going to take the values of all the indexes of the transactions. And as you can see here, the transactions take the index from 0 up to 7,501. So what we need to do here is to take the range by typing in range, the range of all the indexes from 0 to 7,501. All right, so remember, in this range function here, the lower bound 0 here is included, but the upper bound 7,501 here is excluded. So basically what it means is that I is going to take the values from 0 to 7,500. And that's exactly what we want, because all the different transactions take the indexes from 0 up to 7,500. So then we need to add a column here. That's just Python syntax, and then enter. And now we are in the first for loop, going through all the different transactions. So now basically the thing that we want to do is, for each transaction corresponding to each index I here, we want to create a list of the different products of this transaction. And so what we're going to do is simply take the transactions list that we initialized as the empty list here, and that contains all the different transactions, and then we're going to use the append function that will add each of the different transactions to this whole list of transactions. So that's the whole list of transactions, and we are going to append the different transactions of the different customers. Okay, so according to you, what do we need to input in this append function? Well, we need to input the transaction itself within a list. So right now we're in the loop, so the value of I is fixed, so it corresponds to a specific transaction. And so right now, thanks to this append function, we are adding this specific transaction corresponding to this index I into this whole list transactions of all the different transactions. So basically it's very simple. Right now in this append function, we are adding the specific transaction indexed by I. And so now how can we add this specific transaction? Well, we can do this simply by adding all the different products of this transaction. And what are these products? Well, we can get them by taking the right values of the dataset. So what are these right values? Well, these right values correspond to the products in the dataset of the transaction indexed by I, and then we need to take all the products of this transaction. So we need to take all the j's here in this transaction indexed by I, and to take all the j, that's where we use the other for loop. And to use this other for loop, we're just adding here for j in range. And then we need to take all the columns of the dataset. That is, as you can see, the 20 columns of the dataset. So since indexes in Python start at 0, then we need to take the values of j going from 0 to 20. Okay, and now be careful, we just need to do one more thing. We cannot take the values of the dataset this way. We need to add, remember, dot values here. And thanks to this, we will be able to take the values of the dataset. And now we just need to add two things. Remember, we want each transaction to be a list. That is, we want each transaction to contain all its different products within a list. So to do this, it's really simple. We simply need to add some brackets here and here as well. So, now all these products indexed by j of this specific transaction indexed by I are going to be contained in a list, thanks to these brackets here. And now the last thing that we need to do to make this whole list of transactions ready to be the input of our a priori function is to actually set all the products in the transactions as a string. And that's simply due to the way the a priori function is built. It's expecting the different products in the different transactions as strings. And to set them as strings, we simply need to use the str function to set all the dataset.values ij that corresponds to the different products in the transaction indexed by I as string. And so what it will do is that, if we do not use the str function, well, the transactions will simply have the names of the different products, like we have in the dataset. But then if we use the str function as we're doing right now, then the different transactions will contain the names of the products in quotes. And that's exactly what is expecting the future a priori function that we will use in the next tutorial to build the rules. Okay, and now it's ready. We are done with the two for loops and we are done preparing our whole list of transactions, each transaction being a list of the purchased product, for the next step. So of course now we're going to execute this and have a look at what we just made. So let's do it. Press Command and Control plus Enter to execute. And here we go, transactions ready. So first thing you can see is that now the transactions is no longer a data frame, but it's a list. It's a list containing 7,501 elements. So let's open it. All right, so now we can clearly see that this transactions variable that we just built is a list of 7,501 elements, and each is a list itself. And it's a list of the different products purchased by the customer corresponding to this specific transaction. Okay, so let's close this. And we are done with the first step. We are actually ready to train the a priori model on our dataset to find out about the rules. And that's what we're going to do in the next tutorial. So I look forward to seeing you there and start building the rules with you. Until then, enjoy machine learning!